All right. We're going to tie things all together with the intent on sketching the graph of f accurately. And we're going to talk about some straight line motion and talk about speed. So we have a bunch of situations for what pieces of graph could look like. Okay? We need to be comfortable understanding if I have certain signs at the same time, my function will look like this, or this, or this, or this, or this, or this, or even that. Okay? And if you are having difficulty, it's helpful if you start out with something that's just only concave up, only concave down, and then what you'll end up doing is just splitting something that is only concave up in half will give you a decreasing piece and an increasing piece. Splitting something up in half here will give you an increasing piece and a decreasing piece. Okay, so what we're going to do is sketch accurately my original function f given either the function, given its derivatives, given whatever, by understanding it could look like this piece connected to this piece, connected to that piece, et cetera, et cetera, et cetera. Okay? So let's start. I'm going to give you information. I'd like you to copy this down. This is information that we could obtain either from a graph of f prime, or either from a graph of f prime or from a function. And start by copying that down. And what we're going to do is add a third line. And this third line will give us the shape of f. Okay, I'll give you a second to copy down the signs of my first derivative and second derivative, and then to create a third number line for the shape of f. Okay. Each of these points here are interesting situations, locations on the graph of f. So for the shape of f, I'm going to include every single point from f prime and f double prime at the same time. I got -2, -1, 0, 1, and 2. Okay. Now, knowing that f prime being negative tells me that f is decreasing, and knowing that f double prime being positive means f is concave up, I know that the first piece of my function from -infinity to -2 will be decreasing concave up. That looks like this. Now, if you're having trouble figuring out that decreasing concave up is that, again, go ahead and just write on the bottom something that is concave up and concave down and split it in half, because it has a decreasing portion and an increasing portion. Here, increasing portion, decreasing portion. Go ahead and fill in the rest of the intervals and draw the shape of f on all of our intervals. I'll do the second one. Between -2 and 0, we are increasing between -2 and -1, we're increasing in concave up. Increasing concave up looks like that. It comes in my concave up. Which one's going up? This portion. Okay, keep going. Go from there. Good. Okay, looking from -1 to 0, having things stacked, we will be increasing concave down, increasing concave down. Here's my concave down. Here's my concave up. Maybe that'll help you. Decreasing concave down. Here's my concave down. Decreasing is that part. Decreasing concave up. Increasing concave up. Okay? And what I can do is then sketch the shape of F. Now, I don't know exactly where things are going to occur, but at least I know the general shape. Decreasing concave up, increasing concave up, point of inflection, increasing concave down, max, decreasing concave down, point of inflection, decreasing concave up, min, increasing concave up. Something like that. It could be up and down, it could be further up and down, whatever. It's just the shape. We don't know what the Y location is, but we know at -1 there's a point of inflection, 1 there's a point of inflection, 2's are max, 2's are min, 0's a max. All of that, you don't have to sketch the graph of F to understand. You can just be looking at, this to know this is a min, max, min, point of inflection. Okay. But we at least can do a general accurate shape of F. And I can do the same thing. Now, this is easy because I gave you the signs of F prime and F double prime. I can give you the graph of F prime and ask you to sketch an accurate graph of F, at least an accurate shape of F. So you're going to tackle this like you would tackle all the problems that we did for our quiz today, when you have to evaluate the signs of F prime and F double prime at the same time. So you should start by creating your 2 number lines for F prime and F double prime, and then have a 3rd number line, which will be the general shape of F on your intervals. Compare your graph with a neighbor's graph. Good. See if you got the correct shape of F. Careful. You possibly could make mistakes if you do that. See some people doing well, some people not so well. That's a good start. Okay, combine them so that you know what the shape of F looks. Concave down, increasing. Think about something concave down. Half of it is increasing, half of it is decreasing. Yes.
How do you know where it is, like the y-axis?
We don't. So it's just wherever you put it, it's the general shape. Is this F double prime? Which one's F? So you're telling me F prime is negative up here?
Yeah.
Well, the slopes of F prime are negative up there. But the values, the y values are positive. And then they're 0, and then they're positive. And then they're 0, and then they're negative. Yep. So it's increasing concave down to there. And then increasing concave up, increasing concave down, decreasing concave down. So you have it right. Just instead of this section being up here, have that section go to there. Yeah, yeah. That was right. This was right. That looked good. Yeah. Yes. This is good. Negative, positive until 1, negative. So here's the problem. Because you have this here, from -1 to 1, the signs are the same. So it's really the entire section is increasing concave up, instead of connecting two different sections. All right, let's make sure our signs are correct. Some people are struggling. F prime values are positive until I get to -1 where we have a 0. But then after -1, they're positive all the way until 2, which is when they switch up to negatives. So I know I have a relative max at 2. Now F double prime values, slopes of F prime, are negative slopes until I also have a 0 at -1. Then they're positive slopes until 1 when they are 0, and then they're negative slopes after that. So I have 1, 2, 3 points, -1, 1, and 2, and I'm going to connect everything. Now, I don't have every single number everywhere. I'm really looking at when we have zeros or when we have sign changes for F prime and F double prime. So F prime positive, that means F is increasing. F double prime negative, F is concave down. Increasing, concave down, that. Between -1 and 1, increasing, concave up. Increasing, concave up, that. Between 1 and 2, I will be increasing, concave down. Increasing, concave down again. Then between 2 and infinity, decreasing, concave down. Decreasing, concave down. So until -1, I'm looking like that. From -1 to 1, I'm that. From 1 to 2, I got that. And then after 2, I go down. Okay? Sometimes it's tough to see, but literally you could take these pieces and just like plop them together. If you plop them together, there's your shape. Okay? Well, that's all fun and all, but like I said, we don't know where this is occurring. Where is this value? Where is that value? Where is that value? Well, in the future, we're going to be able to actually find those specific values knowing what the graph of f prime is. For right now, we're just guessing. But if I'm given the original function, I don't guess. I can find specific values, x, y values, where these interesting locations are. So I'm going to accurately sketch f, but I'm going to include the correct locations. What do I mean by the correct locations? Well, now I want you to find the y values. I didn't ask you to do that before, even though like the book had you find the y values. But now, to provide a very accurate sketch of what x cubed minus 3x squared plus 3 looks like, you're going to go ahead and analyze the signs of your first derivative and second derivative, which is what we've done a lot of. But then we are going to look at the shape of f, but we're also going to point out, specific points where this shape is changing. Okay, so everybody start out and go ahead and analyze f prime and f double prime and give me your number lines. And give me the shape as well. Yep. Yep. No. Yes. We're sketching f, so we want the locations for f. after we've examined f prime, f double prime to give me my shape of f, go a step further and find the locations of these interesting points, these max, mins, and points of inflections. Plug in your x values into your original function to find out where this is occurring. So I plug in 0, I get 3, giving me the point 0, 3 that I can plot. I plug in 1, giving me the point 1, 1, which I can plot. I plug in 2, I get 8 minus 12 plus 3, negative 1, giving me another point that I can plot. And what's great is that I know the shape of f that is connecting those points. Increasing concave down, I'll do a better job of that. Increasing concave down, decreasing concave down, decreasing concave up, increasing concave up. Now this is a good graph of f. Okay, we know that we have a max at 0. We know we have a min at 2, but we know the specific points at 0, 3, the min at 2, negative 1. We know we have a point of inflection at 1, but specifically the point of inflection is at 1, 1. Let me go from there. Okay, any questions about that? Okay, let's talk about increasing and decreasing in terms of straight line motion, and to introduce the kind of straight line motion problems we're going to be dealing with. Let's start by tackling this problem, which we can do. I'm giving you a function, 1/3 x cubed minus 2x squared minus 5x, and I'm asking you, when is f prime increasing? Yes, when is f prime increasing? Go ahead. Should all be able to do this, and once we do this, we'll go from there. Let's see if anybody will fall into the trap. But you fell into the trap. Miss Elslip, you fell into the trap. Spearman, you fell into the trap. Miss Bichette, you fell into the trap. Mr. McCausey, trap. Ms. Putman, you fell into the trap. Mr. Steffes, you fell into the trap. You gentlemen did not fall into the trap. What's the trap? Well, the trap is, when is f prime increasing? Everybody says, oh, okay, well, let me take the derivative. I get x squared minus 4x minus 5. Let me set that equal to 0. I'll factor. I got x minus 5, x plus 1 equals 0. So I got 5 and negative 1. Let me put negative 1 and 5 down here. And this is my signs of f prime. And it's going to be positive, negative, positive. So it's got to be here and here. This is wrong. Why is that wrong, Ms. Bichette Bonilla? Exactly. This is when f is increasing. Remember, the derivative tells us when f is increasing. Remind yourselves, and you should have written this down after our lesson number 2, something is increasing or decreasing if its derivative is positive or negative. If I ask you what is f prime increasing, this is when f double prime, which is the derivative of f prime, is positive. So I actually need to go to the second derivative, get 2x minus 4, look at 2, and then it's positive to the right of 2. This is when f prime is increasing, between 2 and infinity. Okay? This is a good lead up to straight line motion in dealing with velocities, accelerations, when they are increasing or decreasing. So I have a question. If position is cos t minus 2t is velocity increasing or decreasing when t equals 0. Go ahead and tackle that. Make that plus 2t, excuse me, plus 2t. Doesn't really matter. Oh, wait. Make it 2t squared. That'll be good. A lot of people trip up on this problem because they find the velocity function, which they know is the derivative of position, and they say it's negative sine t plus 4t. And then they go ahead and find the velocity at 0, and they say it's 0. They say, well, the velocity is 0, it's at rest, so we're neither increasing nor decreasing. But that's not what increasing and decreasing means. It's what is happening at this location. Is my velocity going up at 0, 0, or is my velocity going down at 0, 0? That's the question. So this tells you nothing besides that at 0, I'm not moving to the left or to the right. But are my velocity values going up or my velocity values going down? You figure that out by looking at the derivative of velocity, which is acceleration, which will be negative cos t plus 4. I plug in 0, the derivative of my velocity would be negative 1 plus 4, which is 3. This is positive. Since that is positive, my velocity is increasing when t equals 0. Why? V prime is positive. The derivative of something, the sign of the derivative will tell me if something is, the original thing is increasing or decreasing. Okay, this tells me what my velocity is, but it doesn't tell me if my values are going up or down. That's the whole part of increasing or decreasing. Are your values going up or down? Okay, so keep that in mind. When something is increasing or decreasing, its derivative is positive or negative. Well, now we're going to talk about speed, and speed increasing or decreasing. It actually is a little bit more complicated than the derivative positive or negative. Why? Because speed is the absolute value of velocity. It's velocity without direction. So for the previous problem, if I changed this to is the speed increasing or decreasing, well, I'd have to look at the absolute value of velocity and take that derivative. Well, I don't really want to do that. So I need to think about things differently. Okay? Let's look at when something's speeding up. It's important to understand that things can move in multiple directions. In this class, we like to just keep it on a one-dimensional plane. So either to the right or left, up or down. Remember, if velocity is positive, we are moving to the right. If velocity is negative, we're moving to the left. You'll have a question on your homework which saying, when is your particle moving to the left? You need to figure out when your velocities are negative. How do you figure out when something's negative? You first find when it's equal to 0, and then you'll examine your signs in between those zeros. So if your velocity is 0, you are at rest. You are stopped. Now, important thing to know is that you can speed up moving to the left or to the right. And it's all about the signs of your velocity and your acceleration. We should be familiar with this dude. Here's the guy. Now, if I give him a positive velocity and 0 acceleration, is he speeding up at all? No. He's going to have some acceleration to speed up. His velocity is constant. That means acceleration is 0. He's neither speeding up or slowing down. The important thing for speeding up is that velocity and acceleration have to be going the same way. He was speeding up going to the right. But I could speed up going to the left if my velocity and my acceleration are in the same direction. He is speeding up going to the left. Okay? So something is speeding up if we have the same signs for velocity and acceleration. We can start with that. So if velocity is positive, acceleration is positive, we're speeding up to the right. I said positive, don't worry about it. If velocity is negative, acceleration is negative, we are speeding up to the left. Okay. Guess when something's slowing down? When the signs are different. If I give my guy a positive velocity but a negative acceleration, as long as he's moving to the right, he's slowing down to the right. Now, right when his velocity is 0, he's neither speeding up nor slowing down. He is at rest. The acceleration is negative. That means my velocity values are decreasing, right? Well, look, my velocity values go from 4.1. Oops. Back over there. My velocity values go from 3.5 to 0. Now they're going to negative. So my velocity values are decreasing, but until I get to 0, we say he's slowing down. Now he's speeding up to the left, slowing down. Speeding up, slowing down. Okay? So we are slowing down when velocity and acceleration have opposite signs. I have one example to do, so hang tight. Mostly because I'm recording this. Okay? Really 2 examples, but we'll just do one and then I'll release you. So I can be given a function for position or velocity and asked, are we speeding up or slowing down at a specific location? I could be asked just in general, when are we speeding up or slowing down? I'll do all 3 of them. But if I'm looking at a specific location, all I need to do is evaluate and look at the signs of my velocity and acceleration at this value 2/3. So I have my velocity already. I need to find my velocity at 2/3. I don't care what the value is in relation to this question. I just care that the sine of 2 pi over 3 is positive. Since I know it's positive, I know I'm moving to the right. Now the acceleration, which is my derivative of my velocity, would be cosine of pi t times pi. Don't forget the chain rule. You need to multiply by the derivative of the inside. And my acceleration at 2/3 would be the cosine of 2 pi over 3 times pi. Well, I know that's negative. It's in the second quadrant. Cosine is negative. Since my velocity is positive, my acceleration is negative, at this moment, we would say I am slowing down. V is positive, A is negative, we're slowing down. I could ask, given the graph of velocity of a particle, when is the speed of the particle increasing or decreasing? Well, this is just like given f prime, what is f doing? We can examine both the signs of velocity and the signs of acceleration, knowing that acceleration is just going to be the derivatives of my velocity. Now I'm starting at 0. I don't know what's going on to the left of 0. So in this situation, really start your number line at a point. My velocity values are positive until I get to 2. They are negative until I get to 4. And they're positive after 4. So good, I know I'm moving to the right, then to the left, then to the right. But what about the acceleration? The derivatives of my velocity. Positive until I get to 1 where it's 0. Negative until I get to 3 when it's 0. And then positive after 3. Now, when am I speeding up? Let's just talk about speed increasing. When am I speeding up? Well, when my signs agree with each other. From 0 to 1, I'm speeding up to the right. From 2 to 3, I'm speeding up to the left. From 4 on, I'm speeding up to the right. Okay, because my signs are both positive, then both negative, then both positive. Finally, instead of looking at a specific location, like for this one, I looked specifically at 2/3, I could just ask you, when are we increasing with our speed given a position function? Now let's change this to that. Positive t cubed. I would find its velocity, set it equal to 0. I feel like we've used this specific function multiple times. We get 0 and 2. It's going to be positive, negative, positive. And then I would also find the acceleration, which is the derivative of velocity, which is 16 minus 6. We get t equals 1. Or positive and negative. When is the speed increasing? When our signs agree, which is from 0 to 1 and 2 to infinity. Okay, it's really the same thing as what we've been doing, just different context.